Good morning. We have just a couple things to finish up in Chapter 1. Um, I had shown you how to work on stem plots, among other things, last time. One thing your book may ask you to do in the assignment, I'm pretty sure they do, is occasionally they'll say to you, we think you should split your stems. Okay? Basically, this is an issue related to how you treat your hair. No, not really. That would be split ends. I'm sorry. But with split stems, here's the deal. Sometimes when you do a stem plot, I should know it's way too early to try to do any humor. But when you do a stem plot sometimes, well, here's an example of a stem plot on the top. Nothing wrong with it. The problem is, though, do you notice how how the leaves on one stem are really long? And, if we turn this to the side, it's not a very wide histogram. It would be better if it was spread out. So this is almost too few. We said about too many bars is no good. Well, too few is no good. So sometimes what they'll say to you is, split your stems. And here's what they mean. Instead of just having one stem for each first digit, we do two. So instead of 1, 2, 3, 1, 1, 2, 2, 3, 3. And then the top of each one, you only put the leaves that are 0 through 4. And then the bottom part of the one, only put the leaves that are 5 through 9. So in other words, you're just kind of splitting it in half. The result is you get a histogram that's more spread out. So sometimes splitting stems is very simple, but let me rotate both of these, then we'll just instead of having you guys hurt your necks here, here, we'll just put these two side by side. You see, if you think of really stem plots or histograms, and the one on the right tells you more about the data. Instead of having one really, really long, or just a couple really, really long sets of stems, here it's a little bit more spread out, and it tells you more about your data. And so, occasionally, you will see them talk about split stems. Does that make any sense? Something that you're going to want to, let me put these back here. You're going to want to be able to, well, you want to know what they mean, and you should be able to, it's not a very difficult thing to do. Okay, the second thing I needed to talk about today is something called time plots. Actually, this is a little bit of an introduction to what's coming in Chapter 2, where we're going to spend more time on it. It's kind of a special case of a bigger thing called a scatter plot. A time plot comes up, though, in Chapter 1, so we need to talk about it. A time plot. For the first time, all of Chapter 1, everything we've plotted has always been one variable. But with a time plot, we actually have, for the first time, two variables. So instead of just making bar graphs a certain height, now we've got two coordinates. We've got year, or, however you're going to keep track of the time, usually by year, and then whatever it is you're watching will be on the y-axis. In this case, problem 110, page 20, is, let's just take a look at that as an example. Page 20, problem 10, says, it's called vanishing landfills. We always hear about the bad news, but I guess at least this is good news. We have a lot less landfills than we did in the year 1988. In 1988, there were 7,924 of them. In 2000, there were only 1,967 of them. Of course, they're probably unbelievably large in size. I don't know if you know, actually garbage is a huge problem. I don't know if you're aware of this, but New York doesn't have room. They don't have any land. So how are you going to make a landfill? They actually ship their garbage by barge to New Jersey. Okay? Be a nice job, wouldn't it be, transporting garbage? But anyway, they actually have to export their garbage. But anyway, at least there are, yeah, not a great thought, is it? But at least there are less now than there were before, and I guess that makes it a little easier to manage them. Some of these, I don't know if landfills get to be, what, they actually wind up with these huge mountains. And I know there are a couple communities, I think Racine, Wisconsin is one of them, that has made their landfill into a ski hill. So after years, this mounts up, and they will, then they put soil over the top, and made it into a ski hill. I mean, useful things like that. Of course, there are problems. When you put all this stuff below the ground, what happens? Well, all kinds of weird gases need to escape. I don't know how many of you have ever driven on I-94 way on the south side of Chicago, almost getting into Indiana. Anyway, there's a huge landfill down there. And when you drive by, it's this huge mound, several mounds, and there are these little stacks, almost like a smokestack coming out. And if you look at the top of the stacks, there are flames coming out. They actually are burning some of the escaping gases that are coming out. I mean, this is not a bad thing. I'm just reporting to you that there are these problems. Have any of you seen what I'm talking about? Nobody? It's not a great place to drive, but when I used to live in southwestern Michigan and had my relatives over here, I made a lot of trips around the bottom of Lake Michigan, and I would pass that place, and it's kind of interesting. Well, I don't care what kind of time of year it is, those little stacked pipes are coming out of this, and flames. It just looks kind of weird. Well, anyway, sorry, I got off the topic. We have, in this table, do you notice two variables? What year it was, and how many landfills there were. I've got the data up here. It's a little bit smaller, but I've got it compressed into just two columns. One column for the year, one column for how many landfills. And let's, the idea is to produce a time plot. Now, first piece of advice here is, when you make a graph of how many landfills there are in different years, what is it that you really want to be watching? You want to be watching the years? Or do you want to be watching, are you really interested in how many landfills there are? Isn't it the number of landfills in this case? Whatever item it is you really want to know about, that should go on your vertical axis. Let me explain why. It's just kind of a weird fact of life that when something is standing up, it looks longer than when it's laying down. It's the way our eyeballs work. So I don't know if you've ever done this, but there's an optical illusion like this. You take two rulers that are the same length, put one up, put one laying sideways. The one up and down always looks bigger. Okay? We're more attuned to the vertical. So anyway, it's important that you put the thing you're really watching on this axis over here. And then your time, in this case years, can go along the horizontal. Okay, then just like with any graph, you need to make some decisions on units, how big we're going to make things. Let's see, going along, let's just say the years down here. We could probably have each year be a notch, so we'll have this be 88. And I'm going to not write it on every, but each line stands for a year. Do we have room? Well, that's all right. We'll wind up going a little bit over our data, but that's okay. And then I think we can have, what do we have for landfills? We go for, all the way up to, well, we could have 1,000 be each line. So I'm a little bit off on my lines here. I don't know how that happened. Let's see if I can move this up a little bit. Okay, so let's have this be 1,000, 2,000, 3, etc. And that'll be accurate enough, because that'll bring us up to 8,000, and that's as high as we need to go. Okay, now really, if you had a little bit of math, and I know you did, really each of these is just like an ordered pair. If I put a pair of parentheses around it, put a comma in between them, right? 2, 3, remember how to graph those? We're right 2 and up 3. Well, likewise here, we're going to go over to 1988, and we're going to go up to 7,924. And we just estimate this as best we can. So somewhere up here would be our first dot or point. The second one is what? 1989 and 7,379. You know, halfway up between here would be 7,500, right? So I'm just going a little bit below that. Our third point is what? 1990, 6326. 1990, 6326. So somewhere about in there. 1991 is 5812. 1992 is 5386. 1993 is 4482. Just about right about in the center of those two. 1994, 3558. 1995, 3197. 96 is 3091. 97, 2514. 98, 2314. 99, 2216. And 2000, just below 2000. Okay, there's a time plot. Now, you don't want to connect the dots, at least officially. I mean, you can connect them in your head and say, hey, we got a trend here, and this is a positive trend. It's heading downhill. That is if you're happy about having less landfills. You'll probably also notice it's maybe curving a little bit. And this makes sense. This can't keep going downhill in a straight line, can it? Because that would mean, if this really went in a straight line, that would mean by now, 2005, 2006, 2007, we would have 0. And we know that's not going to happen. How can we possibly have 0 landfills? Maybe someday when we have all recyclable things, but that's not going to happen for maybe ever, right? So what's happening here is this is probably going to do more like this, where they maybe slightly decrease, but they're kind of leveling off. Well, anyway. Okay, so a time plot, we're looking at 2 variables one more time. We're looking at over time, what happens to the number of landfills. The main thing we're looking at is this height. And we see a trend here. That's a time plot. Actually, we're going to be calling that, in general terms, in Chapter 2, we're going to be calling it a scatter plot. Because it works for things, not just for time, but works for a lot of things. I think they're going to ask you to do a time plot, and they do get into time plots. So I want to tell you, I don't know if you have any questions on those things today, or do you have any questions from last week? I have your first assignment for you. 1 through, and I'm going to have this due. Let's see, we're going to have to think about this. Today's Monday. Yeah, you should be able to have this done by Wednesday. 1 to 29, and by that I mean 1.1, 1.3, 1.5, the way they number them in the book, etc. 1 to 29, the odds, and then I'm saying skip 11, but I want you to add on number 33. Okay, so 1 to 29 odds, don't do 11s, add number 33. Your first assignment, remember that the deal on that is I will sometimes collect assignments, sometimes I won't. Usually there will be, I'm almost positive that on Wednesday, in addition to you being ready to hand it in, even though it's due that day, I will take some questions about some of the problem spots. Oh yeah, and don't forget, I want part of the assignment, I'd like you to kind of do half using manual techniques and approximately half of them using Excel. That means you have to do your Excel printouts, and you gotta, it's a little bit harder to carry things around. You can't have everything in your notebook. You gotta have some of these printout sheets too. Okay? And it's not ideal. When I ask to collect them, it's like half notebook paper, half computer paper. That's okay. It's best. It's a tiny problem. Maybe have a, I don't know, paper clip along or something just in case I do collect. Okay, so then for the rest of the class today, I'm going to show a video. There's a really good series that I sometimes will use. Sometimes I'll have you guys view them on your own. Sometimes I'll give quizzes on these things. So you really need to take some notes, and not every little detail, but try to get the big things down from the notes. Also, this should nicely, confirm the things we've been going through in class. Okay, I'm going to stop the recording here.